All right, in this video, we're going to do some examples of molar concentration calculations and preparing solutions from a solid using the weighing method. So let's go ahead and take a look at how to do this. Let's go to example number 1. Sodium carbonate is a water softener that is a significant part of the detergent used in a washing machine. A student dissolves 5 grams of solid sodium carbonate to make 250 mils of solution. So let's underline a couple things here. 5 grams of solid sodium carbonate to make 250 mils of solution to study the properties of this component of the detergent. What is the molar concentration of this solution? So first of all, let's write out our formula. We know that C is equal to N over V. We have our volume, which is equal to 250 mils. But remember that this needs to be in liters. So divided by 1,000, that's about 0.25 liters. I'm keeping it to 2 sig figs because that's what I have here. Now we don't have the moles. Okay. What we do have, though, is our mass of sodium carbonate, which is 5.00 grams. So we have to convert this to moles. So it'll be our step 2. Sodium carbonate is Na2CO3. So you do need to remember how to write formulas out. And we need to convert that to moles from mass. So remember that the mass is equal to moles times molar mass. So the moles is equal to mass over molar mass. So we can write that the moles is going to be equal to 5.00 grams over the molar mass of sodium carbonate. So the molar mass of sodium carbonate, let's see, that's 12.01 for the carbon, plus 48 because there's 3 oxygens there, plus 2 times 22.99 for the sodium. It's going to be 105.99 grams per mole. And so we can cross out grams. We'll get moles, 5 divided by that answer there, 0.047174261 moles. And so now that we have our moles of Na2CO3, we can do our last step, which is going to be the C is equal to N over V, which is 0.047174261 moles over the volume, which is 0.250 liters. So divided by 0.25, and we get 0.188697046 moles per liter, which is approximately, according to sig figs, we need 2 sig figs max, so 2 sig figs, 0.19 moles per liter. So that's how we would go ahead and prepare our solution. We would have to so we would weigh out, let's draw this out. Let's do a quick sketch to show you what that would look like. So you'd have a balance, and on that balance, you would weigh out your sodium carbonate, Na2CO3. And so it would be 5.00 grams, for example. And that would be your step 1. Your step 2 would be to grab a volumetric flask. And this volumetric flask is a 250 milliliter volumetric flask. You would take the solid and put it into that flask. So that's step 2. And then step 3 is basically adding water to this. So you would take some water, distilled water, in our little water bottle over here. It's a very bad drawing of a water bottle. And it would go into here, halfway, roughly, stir to shake to dissolve, and then continue filling it up until you get to the etched line here, up until the meniscus is here. And at that point, you can just kind of cap it and store it. or cap it and then put it in other containers or store it, and you're good to go. That was my very poor drawing of what basically takes place, but it's essentially this here. So just we'll pretend this is sodium carbonate, pour it into the volumetric flask. That's 250 mils. Add your distilled water until it's halfway. Make sure it's all dissolved. Add up until the etched line. Shake, and you're good. And it's all done. So that would be your 0.19 molar solution. So therefore, the molar concentration is 0.19 moles per liter. Now in this lesson, I'll often shorten concentration by using these square brackets over here. We often use that. So I might say, for example, concentration of NaCl. That would mean the concentration of NaCl. Okay, so you can use those square brackets to write out concentration instead. All right, so that was our first example. As usual, I do like to check my answers to make sure that I'm on the right track. So for this one here, you can check your answers by going to our unit calendar over here, and you can see the filled in version. So if you look at the filled in version, you can see that we have 0.19 moles per liter, and that's the concentration that we ended up getting, which is good. We're on the right track with that. Perfect. So let's go ahead and try a few more. Another example here. Let's do the sodium hydroxide is a main ingredient in many drain cleaners. Suppose 125 mils of a drain cleaning solution is prepared by dissolving 8.2 grams of sodium hydroxide in water. What is the molar concentration of the solution? So it's the same idea as the previous question. You can even pause the video and try it yourself. So we want to find the molar concentration, which is C is equal to moles over volume. What do we have? Well, we have the volume. So we have the volume is 125 mils. But don't forget that needs to be in milliliters, divide by 1,000, so 0.125 liters. And we have our mass. Our mass is 8.2 grams of sodium hydroxide. But we need the moles. So let's go ahead and convert that to moles. We know that the mass is equal to moles times molar mass. So the moles is equal to mass over molar mass. And so that's going to be our molar mass of sodium hydroxide. So let's do our moles is going to be equal to the 8.2 grams over sodium hydroxide's mass is 16 plus 1.01 plus 22.99 over 40.00 grams per mole. Cancel out the grams there, and we get 8.2 divided by, actually I think I missed something. So 16 plus 1.01, I forgot the hydrogen, that's right, plus 22.99. Oh, that works. Yeah, that works out. I didn't forget the hydrogen. So let's just write that out. Always, one mistake I made is I should always write out what the formula is for the compound we're dealing with, because it's really easy to make a mistake with the molar masses. So NaOH, that's good. And so let's go ahead and do that. 8.2 divided by 40, and we get 0.205 moles of NaOH. So now that we have that, we can go ahead and do C is equal to N over V, which is equal to 0.205 moles over the 0.125 liters, and we get, divided by 0.125, 1.64 moles per liter. And I think we need it to 2 sig figs, so which is approximate, because this is 2 sig figs here, this is 3. So about 1.6 moles per liter. And you can write a therefore statement. So therefore, the concentration, let's write down, concentration of the solution is 1.6 moles per liter. And you're doing it in much the same way that we saw above. You're weighing out 8.2 grams of sodium hydroxide. You're adding it to a volumetric flask that's 125 mils that you'd select. You'd add your distilled water until half of the round bottom portion is full, half is filled up, and you would shake to make sure everything is dissolved. Then you would add the remaining distilled water until it reached the etched line of your 125 milliliter volumetric flask. So do know how to draw or sketch that situation. The best picture to look at is probably this one here. The only thing you have to do is make sure you label things. So, label what your substance is, label the flask here, label, for example, the distilled water being used. What is this called over here? That's called a balance, right? Electronic balance, volumetric flask. We have a beaker over here. So it's still good to practice naming the equipment so that when you do get the hands-on experience with it, you'll be able to kind of already know what things are just because you've had great practice in theory. So in the next video, what we're going to do is we're going to do some examples where we might have to manipulate the equation a little bit rather than simply find the concentration using the C is equal to N over V formula.